So I'll mention for special events, the hacking workshop this Saturday has been canceled. Lan is feeling sick, so don't bother coming to that one. But after that, we will have them. And we have CCDC invitationals on these 2 Saturdays, December 6th and January 24. Anyone's welcome to come. That's the cyber defense competition. Anybody can come. You do not need to pre-register or be a full-time student or anything like that. They're invitationals, which means they're just practice events that don't really count, so they don't have to bother with any rules. And I like that best. It's best for my students. So you can come see what it's like, how you defend a network while it's under attack. And I highly recommend coming to it. It's worth extra credit in any of my classes, and it's a very valuable thing to do. All right, and there's a guest speaker coming this Monday in 4 days. On Monday at 6 p.m., and there will be food available. You should RSVP so they know to get enough pizza for you. And we'll have a talk on securing critical infrastructure. It will happen instead of my CNIT 125 CISSP class. We'll meet over in the STEAM building instead of here in Science, and that's what we'll do. I don't know if it's going to be recorded or streamed, though. When I find out, I'll put it on this page. So we're down to here. We're coming to the end of this class. The semester is coming to an end. So we're going to do Chapter 11. And as you can see, just 2 more classes with lectures and 1 without a lecture, and that's it. Not much left of this class. So let's take a look at this one. This is just some examples of logic flaws, and logic flaws do not have a simple specific cause or a simple specific patch. And these are, by the way, the sort of things that's going to be hardest to address with sort of a scanner or any kind of automated process. Jen Easterly recently said that she thinks that AI code scanners are going to get so good that the security industry, as you know it, will vanish. I think that is hopelessly optimistic. I think that AIs will not be able to catch this sort of thing, but we'll see. So a logic flaw is when a developer makes some kind of assumption that turns out not to be true. And these are real-world examples. So here, you have a remember me function that sets a permanent cookie. Now, this is very common. The remember me sets a cookie with a long lifetime, and that cookie has some meaning. It's usually just a random series of characters that means something to the server. In this case, they chose to put meaningful data in the cookie, which is not a best practice, but they do talk about it quite a bit in this book. We've been there. So the encrypted string has your name, user ID, and some other stuff. But the screen name is also saved in encrypted form with another cookie as screen name. And the problem is what they did was use the same encryption algorithm for both cookies, which is fairly common. You write one encryption algorithm, just use it for everything, presumably with the same key. But the problem is user can control the screen name. And the app that decrypts that cookie that shows the result on the screen. So what they can do is take the remember me cookie that's encrypted and copy it into the screen name cookie using burp. And now when you look at your screen name, it will show you what the decrypted version of that is. So it's Marcus, and then some kind of number, and then some kind of IP address, and then another number. So just change the screen name to admin1, assuming this is the user ID, and the admin's ID is usually 1. Just change the screen name to this, and then let it encrypt it, look at the cookie, and then copy the cookie back to the remember me cookie, and now you're the admin. So you were able to use the encryption algorithm in the web app with, even though you don't have access to the code and you don't know the secret, you can use their encryption routine to break in. And I remember something very much like this happened to Facebook about 8 years ago. There was if you did a password reset, it would send you a long random thing to be in the URL you clicked back, and that same random thing was used for some kind of tag on the page, like an image tag or something. So you could go to someone's wall and look at the source code and find the random thing that would be sent in a password reset. Where's the STEAM building? It is, yes, it's the new building across the street from the Science Hall. Yeah, it's the new one in that building. It's next to what we used to call the multi-use building. Now it's called the Harry Britt building. Yeah, it's the new one. It's very nice. They have nice big rooms that are very pleasant, and so we like having special events there where a lot of people will be there, and Pacific hackers will be there. All right, so that's the attack. All right, so that's one of them. So if you want to detect this sort of thing, look for things that are encrypted, not hashed, substitute other values, and see if you can cause an error that reveals information. So there's password change functions. So the password change function that a normal user would use asks for username, your old password, and your new password. But suppose you want to change the password and you don't know the old password. Well, the administrator can do that, and they have a form that goes to the same script, but it just doesn't ask for the existing password. And so if you just remove the existing password in burp, When a request comes in without an existing password, they take that as an indication that it came from the administrator. And this actually happened to AOL. So this is like the one I was talking about in the news, where they take a user agent or a referrer of localhost, and that makes you the administrator. This is, you shouldn't let anybody be the administrator from some kind of weak clue like that. They should have to really go through an authentication process to become the administrator before they get administrative rights. But a lot of people do sleazy things like this because they just don't know how to write a reasonable authentication code. So what you do, delete your parameters one by one and try it all over the place and see what happens when parameters are missing. See if you have interesting results. So here's a 4-step shopping. You add your items to your shopping basket, you finalize the order, you enter payment information, and you enter delivery information. And of course, the developer assumes that you go through these pages in that order. Now, they could enforce that by having a random hidden field on every page, which is verified on the next page, to verify that you did indeed come to page 2 from my page 1. But if they didn't do that, then users can skip through the pages. And so all you have to do is jump from step 2 to step 4, and you'll get the product without paying for it. How to access localhost to act as an administrator? Well, I think you just changed the referrer header to localhost. At least that's what it sounded like to me. All right. If you want to actually come from localhost, there is a more complicated technique where you make a DNS request that flips. It's called DNS rebinding. You make your DNS request flip between 2 addresses, one public and one localhost, and you can actually use that to make requests that appear to come from localhost in all the headers. But if you can just change the referrer header, that's just there to change. It's like the caller ID in a phone call. You can just write anything you want in there, or the from address in an email. You can just put anything in there, and it's never verified anywhere. All right, so to check this, try skipping step, try doing a step more than once, try to guess what the assumptions are and violate them, and see what you get, what error messages and what interesting results you get. Here's a somewhat more complicated one. So apps are going to let users ask for insurance, and then they'll get a quote, and they can apply for it. There's a lot of stages. So first you submit basic information about your, information about how much coverage you want. Then across several stages, you fill in your health, occupation, and probably your salary and everything. Then it's sent to an underwriter. An underwriter reviews the details and decides whether to approve it. And each stage uses a shared component to process a data structure, to process all this data that's being added. And all right. And so the assumption is each request will contain only the parameters requested in the current HTML form. This is extremely common. The developers assume that you use my form, which has certain fields, and you don't use a tool like Burp that lets you add and delete and modify those fields. They didn't consider a user who submitted extra parameters. So what you could do is start with valid data, and then later on reset the data in later stages. So no validation was performed on the unexpected parameters, and this allowed an injection that revealed personal information of other applicants, and you could also change your price. You could ask for coverage, the underwriter could set parameters to reject it, and you could then go to a later stage and change the parameters to say the underwriter to approve it, because it failed to notice if you put in extra parameters in the request and they were therefore not verified. So it's a little bit complicated, but understandable how they'd make that mistake. So to test this, try putting parameters on the wrong page, adding parameters from page 1 on page 2 and so on, and see what they do. And here's one where bank customers can register for online banking. So it collects your name, address, and date of birth, and then it mails you an actual physical package through the mail that has instructions and a one-time password and so on, so you have to activate your account. This is the way my credit cards always come. They come in the mail, and you have to call and activate them before you can use them. So they regard it as safe. For a lot of reasons, this physical sending it by mail seems like a very safe process where attackers aren't going to be able to get that. And you have a data structure like this, first name, date of birth, and numbers and so on, all in a database, an object on the server. But the same data object is used for online banking and for registration. And it's all based on the customer number, the unique value. All right, so the attack is you'll log in with valid credentials, you go to the registration function and register a new customer with a different customer's ID now that you're in, and it'll overwrite that other customer's object with a new object. So now you can get in someone else's account. So, this is why I think it's going to be very hard for AI to ever catch this. It's not something you see, just a line of code having bad code. It's a misunderstanding what it means. And when you make a new object, you're assigned a new customer number. Then when you do something like update an address, you feed in the customer number and it believes it instead of verifying all the time that the customer number for every request is the one you're actually logged in as. So this is essentially a horizontal privilege escalation, and this is what tends to happen. The developer doesn't understand that you have to make sure with every request that the user is doing something they're allowed to do and not somehow sneaking over and doing something they aren't allowed to do. And this is why there's so many API flaws. The most common API flaw is there's something important you can do without verifying anything about your authentication. That's a totally unprotected API. But there's this, which is a just somewhat less protected, where you can change the customer number and it doesn't notice that. It just knows you're already logged in, but it fails to notice you've logged in as this customer, not the other customer. So that's the problem. You can write without authentication because this function is intended to be creating a new account. And that's the problem. This could also be used to write onto an existing account. That's the fundamental flaw. All right. And then there's a business limit. Boy, this happened a lot. There was a guy who worked in a bank, I think in France, and he was only allowed to invest like up to $100,000, but he managed to invest billions of dollars and lose it because he was able to defeat the bank's internal system that limited the amount he could invest. And so they charged him with a crime, sent him to prison, and immediately somebody hired him out of there. They thought he was brilliant. So this is one of those rare cases where committing a crime got him a job. I don't recommend this as a way to get a job, but it does happen occasionally. So anyway, here you got an application that doesn't want you to perform transfers over $10,000 without getting special approval. But what you can do, it looks like this. If amount is only allowed to make the transaction, if it require approval, well, if the amount is less than the threshold, then you don't require approval. Otherwise, you do require approval. The problem is this just does if amount is less than the threshold, so all you have to do is transfer a negative amount. No approval is required, and the money goes the other way. You transfer a negative amount to this account. That's the same as transferring that amount out of that account. And that'll do it. And this happens anytime you have a numeric field. This is very common. So people only want you to order a certain number of products in one order, or you can only make bill payments of a certain size, or you can make quotes based on age thresholds, negative values. Any place that expects a number might let you get away with things you shouldn't be getting away with. All right. And another common one, you have bulk discounts. If you buy 10 products, you get a discount or something. And so the developer might make the assumption that all they have to do is look how many products are in your shopping basket and apply the discount. But it turned out you could just add a lot of items to the shopping basket, get the discounted price, and then remove a bunch of the items from the basket, and it would not take away the discount, because it didn't think about that. So you end up getting discounted price when you don't deserve it. And I remember another variation of this I've seen many times. I remember Microsoft would give you like a free USB drive if you signed up for something, and you could just change the request and get like 10 or 20 USB drives for a while. Microsoft caught on pretty fast, but there was, again, a number you could vary on the client side that it believed. And online polls and surveys get hacked this way all the time. You want to only let a person vote once, but unless you make them log into like Facebook or something, so they have to have one vote per Facebook account, then they can just keep coming back in and change their source address with something like Tor and write a script and vote thousands of times. And there's a lot of cases where they have some kind of online poll and a group like Anonymous will skew it and make it have the wrong result by just writing scripts that pass many, many votes. All right, and here's one where they're trying to, it's a network intrusion detection system, and they're going to take user input and put it in an operating system command. So they recognized that this has a risk of command injection. So to prevent that, they tried to block all the special characters. So if you can put a semicolon or ampersand, or pipe in line, or less than or greater than, then you can put 2 or 3 commands on a line. So they wanted to block all these special characters. And what they did was put a backslash in front of them, which if you do that in a bash command line, then it no longer has a special effect. Then it's just a literal character, and it doesn't let you chain more than one command together on a line. The problem is they forgot to backslash the backslash. So if the attacker enters data semicolon ls with a backslash, the application will put a backslash in front of the semicolon, but not in front of the backslash, so it turns into this. The backslash undoes itself, and the semicolon takes effect, and now you can add another command in the line. So this is the kind of thing that tends to happen. All right. One thing that surprises me is how many people do this. They take inputs and they try to scrub it and then use it. You know, it would be much better to just look at the input and see if it has any of this and reject it. If it has any of this, just break it. You show us how to add new referral at localhost. I'll do it later. It's very easy. Remind me of that, Joe. You can change any header parameter. Just copy it to the repeater and burp. You can make it anything you want. All right. Anyway, and so here's another one. You're trying to prevent SQL injection, but unfortunately you're not smart enough to just write prepared statements, parameterized queries, which are the perfect defense. Instead, they're going to try and block the quotes, which is a weaker defense, as you'll see. So they're going to double the quotes, which is what you do if you actually want to store a quote in a database. So if you feed in admin quote dash dash, it will change it to admin quote quote dash dash. And the double quote here is interpreted as a literal quote, so this will all be treated as a string, admin quote dash dash. So that will prevent this from bypassing login. But the attack is, there's also a link limit here. The link limit truncates all input to 128 characters. And so it's pretty obvious that this could undo that, because changing quotes to double quotes adds length, but if you hit the limit, it won't work. So what you do is you put 127 A's followed by a quote. Then the app adds another quote, but the length limit removes it, so now you've been able to inject a quote, and now you're going to get a SQL syntax error, and therefore you can exploit it. So that's the game, and it's pretty obvious. And this raises the more general issue that if you have several validation steps, one step can undo the good of the previous step, and that's why it really would be a lot better to, as soon as you find any funny characters in the input, just reject it and say the user has to put in another input. Why are you trying to clean it up and use it? Why don't you just tell the user there's something wrong with that input? Remember, you can't put any funny characters in there. That would be a lot better. All right, and you have a search function which is accessible archives of data that's only available if you pay, but there is a search engine that will show you how many records are available, and therefore you can perform an aggregation attack where you do a bunch of searches to deduce what's in there. So here they have doc titles like this: annual results 2010, press release on a date. So you can just do a lot of queries. So here they are interested in this company. They find there's 276 articles about the company. So now they look for press release and find no matches, but they believe there's a press release on this date, so they just try words until they find a word like takeover. Takeover is in there, so now you try other words until you find another word, and you'll gradually get words in that article until you learn something about what's in that article. All right, double quotes. That's the question, how do double quotes work? Double quotes work of how you put quotes. If you have a name with an apostrophe in it, like O'Hare, then the way you're supposed to do it in SQL is this. If you want to put in a name with an apostrophe, you put 2 apostrophes there. And SQL will interpret that as 1 apostrophe and store it. It will not interpret it as a special character that's the beginning or end of a string. So this is the correct way to store data that contains apostrophes. That's the idea. It is a really bad idea like this. Parameterized queries is the right way to do this, where you don't have data in here, which can be misunderstood as data from the administrator. You just have a question mark here, and you feed in the data object separately, so it can't be misunderstood as a code object. All right, so this is very much like blind SQL injection, where with a lot of questions, you can gradually learn information about what you're not supposed to know. All right, and so authors have used this to find a password by just guessing, a series of guesses about a password. All right. And this is something I've seen a lot with Elma, which is a common online log for Microsoft-based web applications. And so if an app has error messages or a log you can see that include all the parameters, then of course some of those parameters are going to be the authentication cookie. So you can examine it. So the error message was not built from the browser's information. It came from a stored container on the server side that was not session-based. So that means you can view the error messages from other users, which is pretty common. And so in this case, they had only one log entry stored somewhere, and it would only show you someone else's data if someone else had an error at the same time. So this is quite common when you have race conditions like this, where when people test the application with a small amount of requests, it works fine. But when you put it in production, you have millions of users using it, then two people start doing the same thing at the same time, and it starts to have these collisions of data. So there's ways to exploit it. If you just poll the container repeatedly, then every now and then you'll see somebody else's data, so you can then log the ones that aren't equal to yours, and you'll find other people's session cookies, usernames, and so on. All right, so here's another one where you're logging in with a multi-stage process that people had high confidence in. But the bug is sometimes you log in and you get somebody else's account, they couldn't figure it out, and eventually they found it happened when two users logged in at exactly the same time. So the application stored an identifier in a static variable, and the variable is read back an instant later. This is a classic race condition, which is also called time of check, time of use. You store some data, and then later you come back and read it, assuming it hasn't been changed, but the same data is used by every instance of the app, and every user has their own instance of the app, so some other user might have changed it when you go back for it. That's how you cause it. Typically you store it in like a temp folder on a Linux system, an object, and you trust it to still be there later, which is the mistake. So you use static storage to store something that really should have been stored on a per thread or per session. You know, the stuff that's stored should be tied to that session, and other users should have their own place to store it that's separate. But that people can make that mistake, and that's when you have a brief moment of vulnerability. So to avoid these things, you have to document every aspect of the design thoroughly so you can understand the assumptions that are made. You have clear comments specifying what each component does and what assumptions you've made. Remember in the first chapter we talked about this, you have to take all the data that comes from outside each component and consider what will happen if it's evil. And this is what's hard for developers to do, especially if they haven't got an attacker's mindset, haven't done, pen testing and ethical hacking to get used to this. You think about what would happen if somebody manipulated the data coming in to make it evil, and consider all the bad things that can happen. So you should have a security review where you check these assumptions and see what the user can control that might break those assumptions. And so you think laterally about the potential side effects of dependencies and interoperation, these things. Like I say, I'm highly doubtful that AI will ever get good at this. It's a human task. Anyway, that's all. There's no cahoots about this because it isn't that kind of fact in this lecture. Let me stop the recording.